Okay, we're recording. Welcome to the April 17th, 2021 virtual star party for the Howard Astronomical League. I'm Phil Whitebloom, the president of the club and your host, and I want to let everybody know that this meeting or this event is being recorded, and I'd like to welcome everybody here. So with that, I'm going to ask our team of people who are set up for tonight. By the way, it's clouded out tonight, so we're going to be doing this not only virtually, but we're going to be doing some virtual stuff. And with our volunteers who we're going to be outside with their telescopes, they're inside with them tonight, but they're going to share with us what they're going to talk about and show us, and we're going to kind of rotate through everybody throughout the night, and it's very interactive. All the mics are open if you want, so just ask questions and go on. So I'm going to ask Brad to start and introduce what he's going to show us tonight. Brad?
Sure. Thanks, Bill. My name is Brad Martin. I am a beginner astrophotographer, and I just want to go and show people who, may be curious about how the process works of processing images and how they go from the data that's on the camera to the finished product, and just kind of show my process, which I use mostly free or inexpensive software to do it, and I just kind of want to. That's my plan and we'll see how it goes.
Thanks, Brad. Jim Johnson?
Yes, Jim Johnson here. I'm going to be demonstrating how I stack a video capture of the moon. It's about 3,000 frames. I'll be using HAL public domain free software to do that. And I'll talk about the capture a little bit, go through how I process, stack them, and final processing, and show you the end result.
Thanks, Jim. Chuck?
All right, so good evening. I'm Chuck Cinnamon, live in Mount Airy, Maryland. Tonight, I thought I would start up the backyard observatory so I can show folks how I go through a normal startup to begin an observing session. But then beyond that, I think two meetings ago, I had shared a project I was doing in photometry. Jim Johnson, a couple of years ago had a, this thought about, trying to have like a photometry section. And I thought maybe what I do is just walk through, why we do photometry, what can we do as amateurs in the context of that project that I shared with the group at the general meeting. And again, as you said, Phil, I've kind of broken it up into, bite-sized sections. So as we go around, I'll just share a little bit more each time going through.
Thanks, Chuck. Gene?
I'm Gene Handler. Actually don't have anything planned. Just if somebody has any questions, then maybe I could answer something, or can show some of the photos I've taken, but I'll just listen in and see what happens.
Very good. All right, everybody. So that's it. As I said earlier, this is very interactive, very informal. So you come and go as you please, ask questions at any time. So why don't we just kind of scroll back around here and start where we started with Brad. So Brad, if you're ready to go, just unmute. And you should be able to share your screen.
Okay. Share screen. Okay, can you see my screen?
Yes, we can.
Oh, good. All right, so what I have open here is a program called Deep Sky Stacker, which is one of several free image stacking programs. Now, if you don't know what I mean when I say image stacking, when you are doing astrophotography, it would be really nice if you could go and take an exposure to maximize the amount of light that you're gathering that is, 3 hours, 4 hours long. That'd be great. But real life conditions don't allow you to do that, what with light pollution and the fact that meteors are whizzing around and satellites and such. So what you do is you take shorter long exposures and you stack them up, and the data basically becomes clarified by that process. But you need some type of software to do that. Otherwise, it would take forever. to do this if you're doing it manually. So people have come out with software like Deep Sky Stacker to allow you to do it. And it's very easy to do. Essentially what you do is on the left-hand part of my screen here, I have a thing that lets me open the picture files, and the picture files are the light images that have been gathered. And you just go in and select the ones that you want. Like this right here is, oh, I don't know, it's like 11 gigabytes worth of images here. This is from one night of imaging. And that when you bring it in, they just populate in this list down here. And you also need, when you're going to be stacking an image, you need to have something called calibration frames. So that's where you would take a picture with the lens cap on your telescope to remove any noise that the camera generates. So this program allows you to add those images in too. Now I have a list that I've already made, so you don't have to watch me go in and populate my list here. But I've made a list up of an image that I took over 3 nights, like around Easter, of the Pinwheel Galaxy, which is M101. And so what's interesting is that this is what an individual exposure looks like. And this really doesn't look like much of anything. But when you iterate this type of exposure over and over and over again and stack them together, you're able to pull a lot more data out. And so one of the things that you do before you stack your images is you want to kind of look through them to see whether you've got anything like this one where a satellite has gone through. We don't need that in the stack. So we could, if we wanted to, we could take that out ahead of time before the whole stack gets stacked together. So that's one of the things that you can do. I'm going to wrap this section up here by clicking on register checked pictures, which is going to do something called registering, where the software will examine all the pictures and determine kind of like a score of how good each picture is. And then you can tell it to select the best percentage of the pictures, and it'll kick out the pictures that have the lowest score. But I like to go through and manually kick out the ones that are particularly egregious before I run that. But so if I just hit OK here, it's going to start stacking, and then you can come back to me later.
Brad, how long was each of those images individual?
Oh, I'm sorry. Yeah, so the images are all 2-minute exposures taken through a 90mm refractor telescope. I was using a dedicated astronomical camera, a QSI 163C, which is kind of a mid-range camera. It has a cooler on it that makes sure that every image is taken at the same temperature, which helps with noise issues and stuff like that. And just for like, I don't know, should I show what M101 looks like? Show the final image before I go and do this, you think?
No, just go ahead and do it.
All right, so I'm going to go ahead and start the stacking, and then we can move to somebody else.
How long is the stacking going to take about?
On my computer, probably 20 minutes, but I actually already have a stack like ready to go. I have this already done. All right. How do I stop?
Just go up to your top of your screen. There you go. All right, Jim.
All right, I'm going to pretty much do what Brad did, except for lunar imaging. I'm going to walk you through a couple things describing what I'm going to do and how I'm going to do it. And when I get to the analysis part, that'll run for a couple minutes. So hit Chuck and Gene and maybe Brad again, and I'll be ready to continue with the rest of it when it comes back around to me.
I'm Marty.
Let me see here.
There it is.
Share the screen here. Is my screen up?
No.
Okay, sorry.
Okay.
Oh, here it is.
So while Jim's doing that, if you see this picture of the moon behind me, this is the one you see in the Robinson Nature Center. So that's 150 images stacked and stitched together. to make that moonshot there.
That's awesome. I want to do that.
That was yeah, I got a whole thing. I could do a presentation on that one. I saved all the work.
Okay, I think I'm ready to go, Phil.
Yeah, we can see it.
All right, so this, the image that you see here, this is the video that I captured. It's about 45 seconds. And if you look, you can see the moon shimmering a lot. And this was actually a pretty good night. Usually shimmers more than this. But this is what you're capturing.
What format did you record that in?
This is recorded in AVI format.
Okay.
And let me just go back and hit a couple more things. The camera that I took it with was a
Doing my-
ZWO ASI 290 monochrome.
Can you not talk?
And the capture was on
We're talking.
March
Okay?
23rd. I used 12-inch Meade f8 with a focal length of 2438 millimeters. And the capture software is freeware called Fire Capture. And all the software that you're going to see that I used in this demo is freeware. Brad's case for stacking is just to collect data and pull out fine detail. In the case of the lunar imaging, the case for capturing a lot of frames, and you capture video frames and stack them. Like I said, I captured 3,000 frames in about 45 seconds. So it's really real quick exposures, but lots of them. And the idea is to do what's called lucky imaging and pull out the best frames that was captured during that run, and you'll see how I do that.
So Jim, we're just still looking at your video image there. If that's what
Okay.
you want us to see. Okay.
I'm not ready, I hadn't
Okay,
moved on
I don't know
yet.
if you changed or not. Okay.
I did want to talk about what you see in the image a little bit. Here, you basically see, it's kind of low contrast. You have darker areas like, can you see my cursor?
Yes.
You see darker areas like this, and over here, and then you see some mid-tone areas, like most of the rest of this. And then you see some bright stuff, a crater up here, and some rays off of it. And starting with this mid-tone material, this is your older lunar highlands, heavily cratered, so you can't really see the craters that well in this image, and under the sun being high overhead. This is older material, dating back billions and billions of years. The dark is basaltic lunar or lava floods that came along much later. And beneath this mid-tone material that has been aged by the sun's radiation is light-colored material. So this very recent impact here excavated this light material, so the crater itself is very light, and that light material was thrown out over the top of these older materials. So you can kind of see how the moon ages. I should say the basaltic lava floodplains are less heavily cratered because they've not been exposed to cratering as long as these surfaces over here. Let me switch to another software package, and I'll get my run started and pass it on to somebody else.
If
Okay.
anybody's got any questions, just like I said, just
Yeah, any
yourself.
Any questions while I'm switching over?
Yeah.
I have a question.
Go ahead.
Yeah.
I don't know if you said, what mount did you use to capture these videos?
The mount is a Lost Mandy G11.
Okay, and just out of curiosity, because I do more DSO work, I always use a guide star to keep the guiding, accurate enough to be able to see these pictures. So I'm curious, how are you able to keep your guiding so precise? You don't have obviously a guide camera that you can use when you're photographing the moon, right? How do you do that?
Two things. I get a very precise polar alignment. Up until the last time I was out, which was late March, I was using Paul Master for a polar alignment. I intend to switch to Sharp Cap. That who described that? I think Brad described that. I can't remember who it was. Described that at, oh, it was John Nagy described it at Astro School a couple weeks ago. I intend to start using that. So a good polar alignment prevents drift. And I'm operating at a very long focal length here. So that's just going to amplify your drift. Other things that can be done, and I haven't really figured out how to do that yet, is in Fire Capture and Sharp Cap is you can lock on to a contrasty feature, say this little bright spot in here, I believe is how it works. And it will adjust your mount to keep that feature in the same spot in the image.
Yeah, and Fire Cap, it's automatic. You just click
Oh.
on the feature and it finds it on its own. It stays locked up.
Okay. I just haven't learned how to do that yet, but good polar alignment helps. And you'll see when I get to the later stages, you'll see where there is some drift in the image. Is my screen back up?
Yeah, yes.
It is.
Oh.
And thanks for answering the questions. Appreciate it. It's very cool.
You're welcome.
Did you set the mount?
I was wondering how much space the files take up.
The video file was 6 gigabytes.
You mean in total or
Yeah, the 3,000 frames was 6 gigabytes.
6 gig? Okay.
Were you tracking at the lunar rate?
I was tracking at the lunar rate. Los Mendy Gemini 2 system automatically reverts to the lunar rate when you're on the moon.
That was a good question for everybody. If you're not, when you're doing this, that was a really good question. The lunar rate is different than the deep sky rate for tracking. So most of the upscale mounts have that feature. So
Okay, so is everybody seeing auto stacker now?
yeah, we're
switch over?
seeing the left side of that with the status, and then just to the right side, probably what you're looking at with the image.
Okay.
Yeah.
Okay, so auto stackered is what I use to stack. It takes the AVI video file, brings the whole thing in, and I'm just going to walk through what I do very briefly. And if there's any experts out there that have better ideas, I'd love to hear them because I'm not opposed to learning something. So I've already clicked open, selected the file, and you can see that it's open in the second panel over here. For image stabilization, for something where you're seeing like the lunar surface, you want surface. If you have like a planet where you can see the entire disk, the planet's center of gravity is what it will stabilize on. I don't know that I could tell you the difference between expand and crop, but I leave it on expand. I leave these as in the default. I do use align points. You'll see that in a moment. And then once everything's ready to go, I'm going to click analyze and it'll run, and then I'll turn it over to somebody else. But first, this box right here, you see image stabilization anchor, control click to set. Normally I would set this on my primary target, which is this bright crater up here, Thales. But since it's so close to the edge of the image, it won't set there because the edge of the box is too far from the cross in there. So I'm just going to maybe take that feature right there. So I have that set, and then I'm going to come back over here and run, start the run. And let me just talk through a couple things. It'll be a couple minutes. I do leave these in the default. The status here tells me what it's doing. Here's a list of all the steps in the analyze that we'll go through the first two and stabilize and do the buffering and image analysis. When it comes back, I'll set up some more stuff before I do the stack. Then I'll click stack and we'll run through the rest of it. When I do get ready, let's see, when I do get ready to stack, the stack options right here, I get to select a file format. I usually use TIFF, number of frames to stack. I think I can get like 8 or even 16 different output single stacked files. I'm asking for one. I just want the top 10% or 300 frame of the best frames out of the 3000, and I'll show you how, give you an idea of how that's done. I want my output to be sharpened. Since we're in monochrome, I should have mentioned that this is all monochrome work here. No need to click RGB align, save in folders. It just kind of separates all your files out into different folders depending upon what, say if it's, maybe if I'd selected 10%, 20, 30, and 50%, that would be 4 folders. A number of frames works the same way. And I usually turn on 1.5x drizzle. And I think this is as far as I want to look at my.
And what does that drizzle mean?
The drizzle, it takes, I believe it randomly offsets your picture by a pixel and a half to bring out more detail. I bet Wayne knows something about that.
So the advantage of using a video file like AVI is you can get a lot more files. The image that you see behind me, I took using all individual FITS files, I believe they were, when I did that. So there was 240, and they was huge then. I mean, hundreds of gigabytes. Because they're individual frames.
Just a little bit more to add to that discussion. So right now with the analyze running, it's evaluating individual frame quality, and I'll show you the display. It's going to rank. It'll show you how the quality varied during the run, and then it'll show you how the quality varies from the best frame to the worst frame. And it's also going to that's going to be in the stack part. It actually aligns to frames like Brad was talking about for the deep sky part. Should add that the left panel that I was working in, that's the main panel for controlling the software run. And the right panel is for settings related to the image itself. Like you saw me click on the stabilization anchor. And I think that's as far as I want to go until it finishes analyzing. So let's go on to who's next, and I'll wait till you come back around to me.
Chuck, you're up.
Okay, let's see.
I got to stop sharing, don't I?
Yeah.
You want to stop sharing?
Here.
Okay. So my intent this evening is to give us a little bit of telescope time for the night. Obviously, there won't be an opening of the shutter, but I'm at least going to go ahead and walk through the startup of the observatory, give you a little bit of a tour. I went out and took some images, still images, so that you can see it. Obviously, what you're seeing right here is hopefully everyone can see the screen, right?
Yeah, you might let everybody know where that observatory is.
Yeah. So this is, well, I'm going to show them in just a minute here,
Okay.
Phil.
Okay.
This is a live view inside of the dome. Got a webcam in there. And what I'm going to do is a typical night, if I was going to do this in non-automated mode, there is a way for this whole observatory just to run itself using Bob Denny's ACP software, which you see here. I've got something called an add-on called the Expert Scheduler, which uses a dispatch scheduler where through, to be able to share the observatory with partners that I have, people can use the web, put in their projects, and the scheduler itself using a priority system, understanding the geometries, will determine, when to open up and collect the various projects at the right time. Tonight, I'm just going to do this manually using the observatory control software. And what I'm going to do is just go ahead and run it through startup, and then I'll show you some images. As you can see, I just got a pop-up saying the weather's become unsafe. You can see the red for weather right here in the control panel. So it's not even going to give me the option to try to control, open up the shutter for this evening. But I am going to go ahead and hit run on the startup of the system. So it's going to go ahead and at least begin. Oops, there we go. Begin the startup, and I'll leave up the image of the live image so that you can go ahead and watch as the telescope begins to move. Let's see why. I apologize for some reason. It didn't take my request for running the startup. There we go. Okay, so it's running an automated script right now for the startup, and I'll show you the various equipment in there. But what it's going to do is it's going to first start powering on all the equipment, and then it will connect to the various software packages to run the mount, the telescope, the dew heaters, everything that's in there. And while it's doing that, again, I'll leave the live image up there so that you can see it. What I'll start off with here is this is an exterior image. This is actually looking from a video camera on the eave of my roof out on the backyard to the observatory. And what you can see is the dome, plus adjacent to it, that pole there is a weather station. I'll start with the weather station. So what you have there is an all sky camera. That's kind of the closer thing to you. Actually, it is dark enough, or it will be very soon. I guess the next time when we come back, I can turn the all sky camera on. And it's just another visual thing that I can have when I'm operating remotely to understand, is there an issue going on with the system, or, am I having problems with clouds? So anyways, that's the weather station. Again, here's the all sky camera. You've got a sky temperature monitor plus a rain sensor, and then an anemometer. So, wind is another one of those things that, could shut you down if it's too windy. Inside the telescope, so this is a dew heater system that is actually built into the telescope. There's a dew heater on the primary as well as the secondary. This is a reflecting telescope. Kind of like Jim's, it's 12.5 inches. So the focal length is 2540 in terms of the millimeters. So there's a heater, again, on the primary and the secondary. And the intent is that I keep the primary and the secondary within about 1 degree of each other. And that, avoids dew building up in the system. Somebody asked earlier about guiding. This is the guide telescope that is on top of the primary telescope. Got an Orion star shoot on the back of that, and this is about a 2.5 centimeter telescope. So I get about a degree and a half field of view on this, which is about 3 times bigger than what I have for my primary field of view. This is an electronic focuser. So, the focusing is done by moving the mirror, the primary mirror in and out. It only moves about 30 millimeters in total. So not very much movement, which is really good because it locks it in place. And so when the telescope moves, I don't really suffer from what they call mirror flop when you move from one side to the other. This is the camera on the back. It's an SBIG STXL 6303, and you see an 8-position filter wheel on there. I've got the luminance blue, green, red filters in there, which are used primarily for astro imaging. That's not the primary thing I do. I could really use some astro school because I am not a very artistic person when it comes to using my telescope, but it's something I do hope to do one of these days. The other 4 filters are BVRI, and these are the Johnson Cousins photometric filters, and that's what I'm going to be talking about primarily tonight, and how I use the system for that. This is all the equipment that's connected to the pier. So on the upper left there, that is a NUC. It's a PC Windows 10 computer, which is what's running all of this right now. I'm just remoting into it. And then there's a USB hub. And then below that is a web power switch. So everything, again, can be controlled remotely. And much of it is just automated, in terms of turning it on. And of course, this is the system inside the dome. This is the PlaneWave 12.5-inch telescope. It's on a Paramount MX Plus mount. You can see the pier. And I also have another smaller DO system, which I use for which I'm using on the guide scope. Let me minimize this. And as you can see, while we've been talking here, the telescope has moved to the home position and the system has completed its startup. Now, if I had had this in automated mode, it would have also opened up the shutter. It would have slewed the dome to the home position, and it would have been slaved and ready to go. And then the scheduler would have taken over. Now tonight, my focus is going to be on how I use this, and primarily I do science with this. And believe me, I would call on the border of beginner to maybe advanced beginner or slight intermediate when it comes to science. I have more enthusiasm than capability, but I am working to improve that. I mentioned before that I have the photometric filters in my filter wheel. So you have these BVRI. These are the band passes that these filters allow. For people who are new to astronomy, I'll just kind of give you just a quick primer here. Most of the time when you go use your eye and you look through a telescope, you are seeing the entire visual spectrum, which runs from about 4,000 on this scale right here, all the way up to about 7,000. You're seeing all of the light that's coming, from those objects, through the telescope, hitting your eye. Your eye processes that, and you see all that light. It's all, in a continuum. What we try to do in photometry is we want to break down and only look at various slices of that same spectrum, because there's a lot of information that you can discern about different objects. For instance, our sun. When you look at the visual spectrum from the sun, this is what you would see, within that 4,000 to 7,000. But when you take a measurement of it, say at a B filter, and you take a measurement through a V filter separately, you're going to see different levels of light. And it's because the sun has a very specific spectrum associated with it as as a star that's in a specific part of what we call, the main sequence, or the type of star it is, how hot it is, how big it is, how massive it is, what part of its life it's within. Contrast that to a star like Vega. Vega is a very hot star. It's almost twice as hot as our sun, and bigger, more massive. So when you look at, through say one filter like the B filter I was talking about, and again the V filter, you actually see where these two are almost equal. And again, contrast that to our star, where the B filter is actually less. And what this really tells us, again, just a quick primer, is there are all different kinds of stars. They're all associated with a different, what we call a spectral class. So their spectrums look different. And it's because they have different temperatures. And it's based upon how big they are and how massive they are. So for instance, Vega, as I was showing you, is about here in terms of the type of star it is, how hot it is. I mentioned here it's about almost twice as hot as our sun is. So it's up here almost at 10,000 degrees Kelvin. And then our sun is down here in the G category. So it's a lot cooler, it's smaller, and it's not as bright. So again, what we attempt to do with photometry is use these different slices of the spectrum and learn different things about the objects that we're looking at. And so as I continue on later tonight and tell you about how I go out go plan a project and plan it and execute and process. I'm going to share with you my journey through this particular project, where I was interested in looking at two stars that are rotating around each other in a very short period of time, on the order of about 8 to 8.5 hours. They are rotating around each other, and taking different spectrum, both a B and a B filter. And then how do I plan that? How do I collect the data? What do I do with the data? And then what tools do I use to process to ultimately get to something like this, which is a model of what the system looks like. And this is all software that exists that amateurs, very beginning or bordering on intermediate amateurs like myself, can access and use. And there's also a lot of help that we get from the professional community, as well as an organization called the American Association for Variable Star Observers, that help us undertake projects like this, because this kind of data is very useful to professionals and other amateurs. So I'm going to stop here on that, and then when I come back, I'll just go through some of the planning on how I plan a project and execute an observing session, and then the processing of data and the use of these tools and how do you get to results. So I will stop sharing at this point. Any questions?
Any questions for Chuck?
Jim, you're talking, but we don't hear you.
Chuck, when was the last time you were actually out there inside of the observatories?
Well, I took those images today.
Okay, and before that?
It was probably about a week. I'm somewhat a neat Nick out there. I like to go out and sweep it out to try to keep the dust off it. I'll use kind of a Swiffer on things. I do need to have some maintenance done on the telescope, so I need to decommission it for about 4 weeks for a little bit, and drive it up to Michigan and have it recalibrated at the factory and recollimated. I need some help with that this first time. But I try to get out there about a week and a half. The reason why I built this is I got really interested in doing things like exoplanets and this, and I was doing this work on my back deck. And those of you that take a telescope outside each night know how long it takes to set up a telescope, calibrate it, get it, polar aligned, all ready to go. And invariably something doesn't go quite right. And some of the things that I'm looking at are time sensitive. If you're doing astro imaging, yes, you want to get going as fast as you can, but if you're doing an exoplanet and the planet's not going to wait for you and your telescope to be ready. So, given my travel schedule for work and the headaches it was with taking the telescope out, I was going to wait, until we moved from here to darker skies to build this observatory. But my wonderful wife suggested, why wait a decade? Go ahead and build it now and start getting some enjoyment out of it. So, and I do share it with others. I'd be happy to do observing sessions, or if there are people that are interested in doing some projects or even just learning more about photometry, I would be more than happy, to engage with anyone on that.
Did you say your scope was a reflector?
It is a reflector, yes. Yep. So unfortunately, I can, while I go away, I'll go ahead and move the telescope so that you can see down the barrel of the telescope.
Well, it looked like the eyepiece was coming out of the back of it, correct?
Yes, so I don't use this for visual observing. So yes, what you saw on there was, the camera and the filter wheel on the back of the telescope. Yes.
But isn't that where the marrow is?
So this particular, so it's a CDK. It's called a corrected Dahl cal. I'm trying to remember what the K stands for. So the CDK, the primary, is on the back. it reflects, back up to the secondary at the front of the collection area, and then there's a baffle that goes back down the middle of the primary, and so it comes out the back. So that's the optical path.
It almost seems like that's a SCT scope.
It's very much like it, yes.
Okay.
Yeah. But there is a corrector that's on the back within the optical chain. Try to keep the coma and try to keep your image as flat as possible. Any other questions? All right, I will stop sharing then.
All right. Hey, Brad, back up to you. How you doing?
I'm good. So it's done stacking. So we can take a look at that. So let me go ahead and share my screen.
Yeah, a couple people have just joined a little while ago, so just want to give a quick recap. You don't have to go back through the process, just
Sure.
what you did.
All right. You seeing my screen here?
Yes.
Okay, so this is the stacked image. And so for the people that didn't see what I did before, what I did was I took a bunch of exposures that I took 2-minute long exposures of a deep sky object, which is M101, the Pinwheel Galaxy, which is a really beautiful face-on spiral galaxy that is roughly twice as large as the Milky Way galaxy, but it's really far away, so it looks small. Anyway, so I stacked all these pictures up in this program, which removes a lot of noise and amplifies the light signal when you do this. So if we go back to my file list, you can see the difference. Like, you look at this and say, well, that doesn't look like much. But if we look at what it looked like in the original files, let's see, go back to my file list here. So this is a single unstacked exposure, and you can't really see anything. At least in my picture file here, we can start to kind of maybe imagine to be able to see a spiral design in there. And that's actually what I like about this is more like what you would see through the eyepiece than any finished astrophotography that you're ever going to see. So, if you go and look at finished astrophotos and then go buy a telescope and look through and think that you're going to see that, you don't. That's why we do all the processing. But this actually is, you could get a better view than this through a lot of telescopes. So anyway, before I go on to the next step, which is going to be what we call stretching the image to pull the data out of it, I just wanted to share my own scope, which I have open in here somewhere. There we go. So this is, you guys can see this now, right?
Yep.
Okay, so this is my setup that I captured this data through. So my mount here is an equatorial mount. This is a CG5 Advanced Go 2. I bought this mount probably 11 years ago and then never used it up until about 3 months ago. So there you go. It has my main telescope here is a Stellar View SV90. It's a 90 millimeter, 630 millimeter focal length. It has my camera hanging on the back of it, my QHY 163C. And then if you look between the legs of the tripod, you see this rectangle that's zip tied to my tripod. That is my computer that is running this. I've got a mini PC hooked up to it. It's a mini PC that's designed for industrial applications. So it has a ton of USB ports. It has serial ports, which is unusual in a modern computer that runs Windows 10. And it is completely fanless, so it doesn't introduce any sort of vibrations into the system at all. And then you see there's another telescope that is mounted on top of my bigger telescope. That is my guide scope, which is a 360 millimeter focal length, 60 millimeter objective, which is probably overkill to be used as a guide scope, but I was tired of not having a focuser on my guide scope, basically. So I put that on there and it works pretty good. So this is the rig that we're dealing with for taking the images that I'm going to be showing you.
Yeah. Question for you.
Go ahead.
Looks like you're in a pretty crowded backyard like myself. And I was, galaxy season's tough, right?
Yeah.
For those of us that can't, it's not good for narrowband, right? And you're usually trying to probably shoot in full spectrum. So I'm curious, what filters are you using for galaxy season, or any recommendations on your side?
I am not using any filters at all. I'm pretty new to this, so like I've only been doing this for a couple of months. So I bought this color camera used, and I just do full spectrum, like broadband. Like I'm not doing anything fancy at all. Luckily, like aiming for galaxies with a telescope like this is asking for trouble, because you don't really have the focal length to get a large size image. But luckily my scope is pretty good, so I'm able to punch above my weight class a little bit in that regard. But so anyway, yeah, so no filters, and I don't have any recommendations for filters for you, unfortunately, because I don't use any.
Oh, you're doing good. I mean, to not shoot with any CLS or anything, right? In my neighborhood, at least, is almost an impossibility. So I was just curious if you were.
Well, I'm out in Frederick County now.
Okay.
My skies are Bortle 5 in my backyard.
Oh, never mind then.
So
You're in a much better spot than I am.
8, I think.
I'm in an 8, so that
not as
explains it.
bad. It's not as bad as most places in Howard County. Now, when I was trying to do this at my house in Baltimore County, that's why I never used this, because I used to live in Bortle 10. So, what actually happened is there's a tree in my backyard that fell down last year.
Ooh, yeah.
That's what allowed me to do this. There was no possible way I could do this with this tree that was there. I mean, I love the tree. I'm not super glad that it's gone, because the deck is very hot without it. But that's what allowed me to start doing this, is the lack of a tree in the way. All right, so let me go ahead and take this over to Photoshop. So I've got Photoshop open now. Like I said, Photoshop's not free, so it's not freeware. You could do everything that I'm about to do in a free program called GIMP. I have Photoshop, so I'm going to use that because it's easier. So what we're looking at here, this is a single exposure. I just brought that in here just so you could see the difference on kind of a larger field of view here. So this is the single exposure, and then this is our unedited stack that I brought in from Deep Sky Stacker. Now, if you notice, everything looks a little bit green, and that is because the camera that I use is a RGGB sensor. So there's actually 2 green pixels that are captured with every red and blue pixel. At least that's my understanding of the way that works. So if you look at my histogram here, we can see that the green is way farther ahead than the red and the blue. So there's been a few different ways that I've attempted to deal with that. What I'm going to do right now is a really quick and dirty way to do it, which is to adjust my channels a little bit. So, hang on a second. Zoom is kind of in my way. I got to move it a little bit here. Sorry, I'm used to having a much bigger screen real estate. All right, so I'm just going to go ahead and create a new layer to do my editing. When I'm doing image editing, I always do everything layer by layer, so that if I screw up something, I can just delete layers until I get back to a point where it wasn't as screwed up. That's what do they call that? Some kind of workflow, a non-destructive workflow, I think they call it.
That's correct.
Which if you're going to start doing astrophotography, always work with a non-destructive workflow. Because if you get too cocky and think that you can just keep making a bunch of changes, you're gonna end up ruining stuff and then have to do it over again. And then sometimes you don't know what you did to get the result that you had before, and then you never get it back. So always do that. Anyway, so I'm gonna start an adjustment in this layer for channel mixing. So even though I am shooting my images in with a color camera, I'm not using a monochrome camera to get different layers of like red and green and blue and luminance filter. It's all one shot. There's still 3 channels in one of these images. So what I'm going to just simply do here is I'm going to boost the green. I'm going to take some green out of the green channel and put it into the red channel. And then I'm going to do the same thing. Let's see, we'll just set this is the wrong way to do this, but if I do it the right way, we're going to take all day. So I'm just kind of adjusting my image so that now it's got more blue in it than I want, but that's okay. It's not totally green, so that's better than it was. So once you have your channels mostly mixed, then what I'm going to do now is I'm just going to clone this layer. And actually, I should have named this layer channel mix or text mix. And then we're going to look at levels. Now, I'm not an expert in terms of what exactly I'm doing here, like what you call literally everything that I'm doing. So when I adjust my levels, I'm pretty sure that what I'm doing is adjusting the black point and the white point mostly is what that is. But actually, I just realized that I skipped a step because I need to identify the darkest and lightest parts of this image. And the way that I do that is with a tool called the threshold adjustment, which I just clicked on my adjustments here. And you want to go in here until everything turns mostly white. And then this black area, anywhere that's still black at this point, is going to be one of the blackest points in the image. And then I just go in and find a star that's nice and bright, and I click that. And what that does is it picks my lightest and darkest parts of my image. And that gives me a frame of reference for when I'm adjusting my levels. If I don't do that, then I don't have numbers. Sorry, my zoom window is like in the way. Can I minute? There we go. All right. So I now I'm going to have numbers in my info panel here that I can look at and adjust. So I'm going to adjust the levels here. The way that I do that is just I select my layer that I made for levels and hit Control L. And I go in and adjust the red, the green, and the blue separately. And what I'm going to do is move all of them so that over here where these values are, and don't ask me exactly what those values mean. I don't know. But what I want is I want to see each one of them. I'm going to set them to be 19. And so I just move this slider forward until this says 19. And I think Astro Backyard, which is a YouTube channel, a tutorial on that, and he was using 19, and that's just what I started using. And then every other value that I've ever tried, I don't get as good of results. So the way that this works is it's the higher a number that I put in here, the lower this number gets. So if I want that to be 19, then I need to set this to be 42. So now I have like a baseline. So red, green, we're going to set this to be 42, and then we're off by 3. So that means that I need to make this, 39? No, not 29. And then we do the same thing for blue. 41. And now, no, you dummy. Where was I at? 37. There we go, 19. So I've got all 3 of these at 19, and you see how much darker my background is on these. That was the goal there, was to get it so that my background is a little bit darker and that these are balanced. So this is where we start to do what's called stretching, and you'll see why it's called stretching in a minute. We click on the curves adjustment, and you just grab, what I do is I grab the center of the curve for the first one and pull it straight to the left. And you see how my image is getting lighter as I do that. So that is bringing out the hidden detail in my image when I do that. And every time I do it, I have to go back and readjust my levels. So I go in and I do the same thing over again. I just drag this in until I get to my my value of 19 that I've chosen. So let's see, this needs to be 25 to make that 19. And then green will set to 25. And you see that this is changing the colors back there as this does this, because I'm adjusting each channel individually. And there we go. Now we do another stretch. Now this time I'm going to do it a little bit differently. We'll set this to about here and make kind of an S shape for my curve, right? And then again, we have to do the levels. So we clone that layer, adjust my levels. Again, like I said, I'm doing this really, really fast and dirty. So, you know, some people will be a lot more careful at doing this than I'm being. 25, no, 20, 27 gets me 19. Does anybody have any questions about what I'm doing here? Can you guys?
Are you doing that on each of the pictures you took? Or
Oh no, actually, this is just the stack. So this is that stack. This is all of those images stacked together in one image that I'm adjusting now. So that's why I have all this data to play with, is because I took all those. What was it? It was 13 hours of data that I'm adjusting. All those images all stacked up on top of one another.
but I mean, every time you're doing this with the numbers, is that going in and working on the whole stack?
It is, yeah, it is. And what it's doing is all these are just different layers. So if I need to undo something that I've done, like if I pull my curve too far and end up blowing out the core of the galaxy and it doesn't look good anymore, I can get back to exactly where I was. Just go ahead
And why are you using this 19 number? What's that significant? I mean, you just found that was a good number to work with?
Yes, that's exactly it. I saw someone else do it with 19 and it worked. And
Mhm.
then that's just what I've always used. And it's worked pretty good for me.
Mm.
I wish that I could speak more intelligently on why that might be or why other values might be better. But like I said, I really just started doing this. So what I'm doing here is I'm adjusting the curve that I just did. I'm adjusting the opacity of it because it was kind of blowing out my image a little bit. So I'm making this layer more transparent. And I'm going to just do one more levels adjustment, and then we're going to start doing a little bit of other final stuff before I say we've got a astro image. I'm not going to say that it would be a finished astro image, but an astro image. All right, my kid's running around behind me now. All right, so we say okay. All right, so here we go. We're going to call this stretched enough. So let's zoom out a little bit. So what's this going on around the edges here? Well, part of it is light pollution. I do live relatively close to Frederick City. So even though my skies are a lot better than you would get in Howard County, I still get light pollution from Frederick. And part of it is when you stack an image, one of the things that it's doing is taking the minor differences between the position of things. And also this is from 2 separate nights of, or actually, no, this is 3 separate nights of data. So the differences in the way that the telescope was pointed, it is actually lined all up. And so around the edges tends to be a little bit messed up. So what you do is you just go and you crop out the parts that you don't want. So I'm going to go ahead and do that. All right, and then I'm going to zoom in a little bit here so we can take a look here. So we can see the pinwheel now. I mean, we can see it pretty well, and I still can get some more detail pulled out of this. So I kind of lied when I said I wasn't going to use fancy stuff because I want to use fancy stuff. So I have some plugins for Photoshop that are specifically designed for editing astro images. And one of them is for removing noise. It's a program called Topaz Denoiser, and it uses it's an AI driven program. I'm just going to go ahead and load it up here. It's an AI driven program, and if you have a video card on your computer that has tensor cores, like a GTX series video card from NVIDIA, it will actually use the AI cores in your video card to denoise your image. So the fact that I have that makes this do what it's doing a little bit faster than it would be if it was all just doing it over CPU. So we can see on this side the original, and then each one of these is a different way that denoiser is doing it. So what I like to do is have all 4 different methods that it uses and then compare each one and decide which one I like. So I like this one. I can also go in here and move these sliders around if I want to, but I'm not going to do that. So, but if I want to get it like looking as perfect as possible, I could go and mess with all these slider settings. And so we can take a look at the difference if I hide this layer. Oh no, I didn't do a non-destructive workflow, guys. That was really good. So I can't actually show you exactly what it looked like before and after, but I got some of the noise out anyway, so we can zoom in and see a little bit farther. So one of the cool things about M101 is these little blobs in here, they have their own NGC numbers. Those are nebulae inside of another galaxy that have their own designations as objects in the sky. If you look at this object through a telescope, depending on your aperture, these can look kind of like separate dealies going on. And I just think that that's really neat and interesting. And then I'm just going to run one more quick filter over this, which is something to get rid of something called gradient. So what this should do is get rid of some of the gradient where it goes from dark to light down here. And we just say, okay. And there we go. So that is a really quick version of doing an astro image. So this is what I did in, I don't know, however long it's been since I've been talking. And then here's one that I took my time on of the same object with the same data. It's a little bit better. So I got more detail out of this one. Let's take a look.
Yeah, it looks great.
You can see the difference there just by taking more care with doing, you know, my curves and stuff. So anyway, this concludes my presentation on doing that in Photoshop.
That was
Any
great.
questions?
So how long were the shots you were taking?
It was all 2 minutes,
2 minutes.
exposures.
For a total of how many hours?
This was 13, I
13
think.
hours, right? That's okay.
Yeah, the data that it used out of in my stack is 13 hours, 12 minutes.
Yeah.
Do you use
How much space that take up?
Oh, I don't know, an obscene amount. I have a 4 terabyte drive that I use for it.
Oh.
Brad, I'll ask for the benefit of the folks that weren't on Thursday night. How did you know when you got done?
Well, it's never done.
I think it was Wayne that said we just abandoned them after a while.
Right. Yeah. Well, yeah. That's right. That's right. Yeah. You just abandon it. Exactly. In my case, I didn't save the working file for this one that I did the best on, and I never got it as good again.
Oh, that was great, Brad. That was a really excellent crash course there, especially since from you, especially being so new to this, just doing this for a few months, it's quite impressive.
Thank you.
Yeah, it really is. Do you use the same general process for nebulas as well, or do you?
Yeah, pretty much. The problem is that it's like when I started actually being able to do this without fighting with the telescope all night, there's not any nebulae that I can get from my house. I really have a very limited view of the sky because there's so many trees around me. So basically I've got Ursa Major right now. Like that's what I can point at.
Yeah, nebulas are gone for now.
Yeah, so I did do one of the first things that I did was the Orion Nebula, of course, and that was one of my favorite images I ever did, and I did it just like without knowing what I was doing at all. Look at that. That was my first finished astro image, and I was just like, wow, I'm amazing. Like, you know what I mean? And then like everything I did after that was terrible for like 2 months.
I had a similar experience. That was the first thing I imaged, and I thought I knew what I was doing until I tried something else.
Right. Yeah. It's like, no, totally.
Yeah, it's a good one to start with for sure. You got to get
Right.
in that.
So what we're gonna do is Gene's got something he would like to show us, and then Jim will jump back over to you. Okay.
All right.
All right. Where's the button to show?
If you're on a PC, go down to the bottom and do a share screen.
Oh, okay. I was looking up at the top.
Yeah, that's how you turn it off.
Yeah. All right. So, wow. So, oh, is this showing my whole screen?
Yeah, we can see everything.
All right. Hopefully. So, Jim was talking about taking a bunch of pictures of the moon. That reminded me of something. So, I thought I'd talk about it. So, back in 2017, I took a bunch of pictures of the sun, actually the moon also, but I didn't stack them. Instead, because what I took was a picture of a solar eclipse. The stuff was changing from one frame to the next. So just stacking them together obviously is not what you want to do. And the other big difference between taking pictures of an eclipse and taking pictures of like deep sky or something is the timing matters. So, you want to take the right exposure for the right stage of the eclipse. And so there's a program called Eclipse Orchestrator, which I won't run, but through lots of practice, hours and hours of practice, I finally got it to where everything was all set up. So all I had to do was when the eclipse started, I pushed the start button, and then I watched the eclipse, and the telescope took pictures for however long it was, 3 hours. And I did have to take the program even tells you that totality is coming, take the filter off the telescope. And so I had to listen for that and take the filter off and then put it back on at the end. And it varied the exposure so that, during the totality, you want longer exposures by how. And so I took all those and I put them together into a movie. And I was actually doing 2 cameras at the same time. One was through an 8-inch telescope and another one was just through a telephoto lens. And so I made this movie, and it was very hard to make. And I don't even remember exactly how I did it, but I can run it. And so what it shows is most of it is the eclipse through the 8-inch, but then in the middle, it shows the eclipse through the telephoto lens. And all the other movements are all that happen are just done through the program. You can zoom in on things or back out. And so it, like in the middle, it kind of zooms in on the sun, but it's really all taken through the same camera. I didn't change powers or anything. But anyhow, so see if I can make it go. So this was the moon covering the sun back in August 21st, 2017. And this is just tons of separate photos put together into a movie. So this is totality. And that's the diamond ring effect. And then I started using longer exposures. Oh, anyhow, and this is through the other telescope. I mean, through the.
Where were you, Gene?
In Tennessee.
Okay.
And then this is it coming out again. This is zoomed in on that.
Where in Tennessee?
There it goes.
It's just how I remember it too, looking at it in Missouri.
Oh, and well, I'll get back to that picture. And then this is the sun moving off again.
Awesome.
That's
Okay, don't do it again. And then the other thing I wanted to mention was the kind of the standard way to take pictures of a total solar eclipse during totality is you take different length exposures. Like you take real short ones to get the prominences, and then you take a whole bunch of different ones to get varying amounts of the corona. But I didn't want to do it that way. I thought I'd try something else. So this was instead what I did was I only took 2 different length exposures. I took very fast ones to get the prominences because the prominences are very bright compared to the rest of it. And then for the rest of the corona, I just took, I don't remember what they were now, like 1/8 exposure. Well, maybe it's faster than that, like 60-second, 1/60th of a second exposures. But I figured by stacking them, I could get the same, you stack, when you take pictures of deep sky nebula objects, you stack them to bring out the dim parts. So I thought I'd try doing the same thing with the corona. So I didn't take any long exposures. I only took short exposures and stacked them to get the dim parts of the corona. And anyhow, so this was the result of doing that. And so I was able to get, all the outer parts and the inner parts. You got all the bright details and the outer parts. And it's just, this is basically just 1/60th second exposure stacked. And then kind of like Brad was doing with mucking around with that curve stretching, it was able to bring out all the different details because it's all in there. It's just, it's all been added together. You just have to get the right brightnesses to bring out the details.
Gene, is that Mercury?
I don't think Mercury was in there, but I don't really remember.
I thought it was maybe the one down at 5 o'clock.
This one?
I think that's Regulus.
I was gonna say, I think that's Regulus.
Yeah, I don't remember Mercury being close to it. Anyhow, so that's what I had.
Oh, that's pretty darn cool.
Yeah, that is amazing.
Yeah. We should show that video at one of the HAL meetings one day. And that's that was really cool.
Yeah, that's a showstopper right there.
Yeah, unfortunately, you can't practice that very much because eclipses don't happen too often. But hopefully everybody knows 2024, I think it's April, there's even longer eclipse coming across the US.
Yep,
Yeah, I'll be there.
that'll be cool.
Be there.
Yeah. When I observed that eclipse, and then there's a whole long story that I won't drag you guys through here with trying to run out of a thunderstorm to get to a clear spot, driving out over 90 miles an hour in Missouri. But you know, it goes by so quick when you're watching it, when you're observing it, you know, so the imaging that you were able, that I intentionally didn't image because I had never seen a total eclipse through, you know, telescope before. So I was really looking forward to it, just observing, but it was so quick, you know, and it was over so quick. Let's put it that way. It was just awesome. But your video, it definitely brings back really good memories there, and it was really, really well done. I mean, it captured everything: the color, the intensity, you know, like you said, the diamond ring, and you could see, you know, the mountain ranges, you know, when you're on the rim there. So that was awesome.
Yeah, the one thing I learned was you got to pay a lot of attention to focus because if you look at it, a lot of that was out of focus. And it's hard to focus on the sun. Well, you know all about this, Phil.
Yeah, that part I do. But, you know, nobody's paying attention to the focus on that because it was just awesome watching what was going on.
Okay, thanks.
Thank you. Back to you, Jim, and back to you.
All right. Just briefly, there's my telescope. Right about the time that the image was taken, that's a 12-inch Meade f8. Like Chuck and Brad, there's a Windows 10 computer over here. I keep this one bundle of cables coming down off of the scope onto the mount, and down here I have a 15 amp 12 volt power supply, runs off a household current. But I try to keep my wires all nice and tidy, especially at night, that I'm not fumbling with all that kind of stuff. So there's my telescope. Let's see. And get back to auto stacker. There it is.
Dave's a legend. So now that you're retired, you can go ahead and do all this stuff.
Who's that?
Yeah.
I'm calling Karen.
Oh.
Show her that this meeting's being recorded. By the way, just so everybody you know, we are recording this session here, and we'll have it up on the HAL site for a month or two, and then we'll take it down because it eats up a lot of space. But you can show it to Karen and Dave, and you can show her what you want for the holidays.
Right. She's already warned me about spending thousands of dollars for equipment. We'll see.
So is my auto stacker screen showing?
Yes.
All right. So pick up where we left off. It's gone. The analysis part, the analyze part has gone through the first two steps. I now have a graph down here. If you look at these gray lines, so this is time from beginning to end. This is image quality on the y-axis. You can see the image quality started low, and then it kind of, you know, went up a little bit, came back down, and then up at the end, and then back down. This image that you see over here is what Auto Stacker picked out as the best frame, or frame number 1. So coming back over here, the best frame is, so the rank ordered frames by quality is this line here. So it starts out at 100% is your best one, and 0% you see that falls off there is is your worst one. And I'm going to select about, as I said, about 10%. So basically, I'm just getting these frames right up here. Okay. Let's see. I think I'm ready to. Oh, I want to select 1.5x drizzle. I got to set my alignment points over here. Why is
Jim,
not?
have you used Registax 6?
I have used Registax. For
My
cleanest,
question is, that's what I use. But my question is, how would you compare ease of use, quality, and all of those two things between the two programs? I like this graph thing, and that doesn't have.
Yeah, I don't remember a lot about using Registax to do this. I do remember somewhere along the way learning that that AutoStacker is better. A lot of people will use AutoStacker to actually stack and then go to Registax for noise reduction and sharpening. I think the sharpening that AutoStacker does is just fine.
Okay.
And I seem to be locked up here. I might have to ask you to skip over me and come back.
Okay.
Yeah, let's do that. I don't know what's going on.
All right. Could you unshare?
I tell you what, let me stop the share and start back and
Okay.
see if it comes back. Okay. I think I'm back in business.
Okay.
Nope, let's come back to me.
Okay. Chuck, back to you.
Okay.
Want to just remind everybody what we had some people join in.
Yeah.
Since you did your everything, you don't have to go back through the whole thing, but
Right.
just catch up.
Okay. So when I showed you the startup of the observatory in the backyard. Obviously, I'm sitting inside. It's completely remoted. I went through the startup of the system. Actually, I was going to just quickly show some of the various software, that I use to control the observatory. Again, this is the web version of the ACP that Bob Denny has developed. So I can actually use this either, sitting right here, or I can sign into this, if I'm on the road someplace, or even one of my partners, if they're using the observatory, they can get into this and actually control the observatory with all the telemetry that you can see here, what's going on with the observatory. Obviously, the weather is not cooperating tonight. You can see all that red, that's all observatory. The scheduler is disabled. That's the automation of allowing the scheduler to have complete control over the observatory, telling it when to open, what to go observe at what time. It's completely hands off when you're using the scheduler. The telescope, you have all the telemetry of where it's pointed, the imager, the guider in terms of what's going on there. It even gives you a thumbnail of the last image that you took, so you can always have see what that was from last night, an image that it took. And then it will show you what plan you're running, and in real time, it will show you the guiding, the tracking errors. And there's a lot of other things that you can look at here, like I don't know if you guys have seen these kinds of charts before, the clear, dark sky. So the folks up there, Environment Canada, were very nice to build one for my observatory, so I can see, what the skies are going to look like. I can look at dawn and dusk times. The scheduler will not start until at least nautical twilight ends, which tonight right here was 8:48 p.m. So I can always know when that's going to happen. This is a tool that gives you a pictorial field camera. So using the field of view based upon all the equipment. Oh, it's very nice. The weather's become safe. I could actually open up now if I wanted. This is computer generated though. This obviously the dome is closed, so this isn't actually what the telescope is seeing, but it kind of gives you an idea of the field of view of the telescope and based on where it's pointing right now. And there's other things, like, all the instruments and equipment. So anyways, this is the control software. Because I use the Paramount MX Plus, the SkyX is needed, and this is the SkyX software. The one thing I was going to show on this is people were asking about guiding before. One of the things I really like about the Paramount is the accuracy of the guiding that you can get, even if you don't have a guider. This is the mount model that I'm using in something called T-Point. And, if unguided, I would have about 9 arc seconds of error just in my pointing. But then there's also another capability called ProTrack, which, when combined not only with the proper polar alignment, I use something called, I'm having a mind, PEC, periodic error correction for the mount. So you can actually, model how your mount drifts over time and put in, changes, and that's based upon the gears. This is still a mechanical system when all is said and done, just like the one we have at Halo. And so you can understand how your system is going to drift just because of the imperfections in gears. But all of that, can, be accounted for. And I can get pretty good tracking over about a 5 to 10 minute period where, for long exposures, I wouldn't really have to guide, but I normally do anyways. The other thing I'll show you is, I mentioned to you before, it has internal do system. So this is telling me the ambient temperature right now is about just under 12 Celsius. The primary backplate is about 1 degree warmer, and then the secondary is 2 degrees. And this is, what it does just to keep dew from accumulating on any of the surfaces for the telescope. Let's see what else. This also has an automatic focuser, so I can do autofocus. Generally, I can select that as part of my planning. Do I want it to, to autofocus, and do I want it to be done periodically? So things like that can be done as well. Okay, so that's kind of the overview of the telescope. What I was going to go into now is, I'm going to walk through eventually, the project that I did on a star, which is TY UMA, which is an eclipsing binary. It's actually a contact binary, meaning that the two stars are so close to each other, they orbit about 8.5 hours around each other, that they are actually sharing material. There's an envelope of material that is engulfing, both stars. But there is a difference in the brightness when they are in eclipse versus when they're not. One star is clearly bigger, or slightly bigger in this case, and brighter. These are both F-type stars. So again, on the, if I go back to, this diagram, the Hertzsprung-Russell diagram, the F-type star, it's a little hotter than our sun. But they're kind of in the middle of the main sequence, and they are both main sequence stars. Not all eclipsing binaries are two main sequence stars. So, one of the first things, is, what are you going to do? What target are you going to pick? Why are you going to pick? And, you get a lot of help from an organization like AAVSO. And one thing I was just going to show you really quick is, they have different observing sections depending upon what you want to do. And one of the sections they have is something about eclipsing binaries. And they actually maintain a target list. So if, they will kind of tell you things that are of interest, to the scientific, the academic community, and even just other amateurs. And they have a list of eclipsing binary stars when they've been observed. And if you actually log in, I'm not logged in right now, it'll even tell you based upon your position, when is it going to be visible? So it really helps you from a planning perspective. So you're not trying to figure out, well, where is that star and is it going to be visible for me? All right, so this is one way of trying to figure out, what you might want to do from a from a project perspective. For me, I used this book. I don't know if it's easy to see or not. It's called The Binary Star Atlas. And the reason why I chose this book and I picked a star out of here is because these are all very well-known catalog stars, have been modeled. And as I mentioned before, I'm kind of a beginner / getting to be maybe intermediate. And I was trying to make sure that my processes, my techniques, are sufficiently accurate before I launch out trying to do stars that have never been observed before and trying to do real science on my own. So I decided I'd pick one out of here, and that's how I picked, this star TY UMA, again, a contact binary. Again, AAVSO has a number of tools. If you're interested in just learning more about different stars, different types of stars, they have one tool in here called VSX, and it's the International Variable Star Index. And you can put in, any star or any type of variable, and it will give you lists of stars, or you can go to very specific ones. In this case, again, picking it out of my book, I was like, well, let me go to, VSX and see what they have on it. And this is what comes up. So it gives you all the basic information, coordinates, proper motion, the variable type, the spectral types, the max range, which is very helpful for determining how long an exposure should I take, already knowing what the range is for the magnitude. But it also tells you, it will give you ephemeris for when the eclipses, in this case, are going to occur, when those, the midpoint of those transits are going to happen. In this case, the epoch, the last time VSX updated this was in 1967. So this became something of interest to me of, hey, is this epoch still correct? The data that was collected back then, it was probably a ground-based survey that was done on this star. And now in the age of satellites, of large ground-based, and even CCD cameras, how accurate is this star, and this epoch that's in this database? And it also tells you the period. So in this case, as I said, 8.5 hours, these stars are whipping around each other. So again, I went ahead and I looked at the ephemeris, and this is for tonight, actually. There's actually going to be an eclipse at 8:11 UTC. So we're 4 hours off. So at 4:11 this morning, there's an eclipse. So this is, again, how I would look at, well, is this something I can do? So again, I'm going to consult, well, what are the skies going to look like? Well, at 4 a.m., hey, the skies don't look too bad, at least from a planning perspective. So maybe this one really is, trying to, worth planning for me. And again, make sure, well, when is dawn going to occur? Nautical twilight going to happen? Do I have enough time to collect both the ingress of the eclipse as well as the egress? So I'll go through those kinds of things. The other thing to understand is, the whole thing is predicated here on something called differential photometry. I am not going to, take a picture of a star and do the analysis and directly determine what is, the magnitude of that star at any given time. I'm going to rely on work done by others, which is AAVSO produces something, these star charts, and you can put in the star of interest, and this is really where the star is, but this is a map based upon a field of view that I asked for, 30 arc minutes, because that's about the field of view of my system. And it's telling me other known non-varying stars that are around here that I can compare my measurement to those stars. And that's what differential photometry is all about. I take a picture in a particular filter. These stars have a known magnitude at each one of those bands, whether it's the B, V, R, or I. And then that comparison is made on a frame by frame basis, and I can figure out, I can get a profile of that eclipse. And so here's a chart that goes along with that. So each one of those stars, so let's take an example. See this one, 110. So that's actually an 11.0 magnitude star. And you can come down here to label 110, and it will tell you in B, that's actually 12.175 for its magnitude. But again, the label is based upon its V magnitude, which is 10.99 or 11. Okay, so that's, all of these stars that are labeled are my comparison stars. So that's another thing I check for. Do I have comparisons? Because it does no good for me to go after a star and then realize I have no comparison stars. Now, AAVSO is really good. The people there are really encouraging of amateurs. They will build star charts at your request for your scale, for stars your interest, and they will do it almost within a 24-hour period. So if you do take an image and you realize, crap, I have no comps or comparison stars, they will build you a star chart pretty quickly if you need it. So, once I have all this information, I know when the eclipse is going to happen. Now I go into my scheduling software, and that's, in real time, I'm actually in it right here. This is the Expert Scheduler browser. This is the, what I'm building in real time here. In this case, I am, instead of allowing the scheduler to determine when to go take the picture, I know when I need images taken. I want to hard code it that 2 hours before the eclipse and 2 hours after, because if I know the eclipse is going to, has some variability here, I want to make sure I get it. So I'm going to collect from 6 o'clock UTC, which is 2 a.m. our time, until 6 a.m. just before dawn. I'm going to try to go collect against this star, just take image after image after image. The other thing I need to do is I got to put in the right ascension index, so I'm giving it its coordinates. And then the last thing here is what filter do I want to use, how long of an exposure, and I just know from experience that about a 12 to 13 magnitude star, I don't want to oversaturate it. I don't want to oversaturate the comp stars either. So about a 90-second exposure, binning twice. Somebody was asking before about how much room do all of these images take? A binned image 2x2 on my system is 3.2 megs per each one. Now, if I go ahead and I take 120 images, I'm going to be about 2.5 or 3, well, actually 3.5, almost 4 gigabytes of data just for one night. I actually have an 8 terabyte hard drive in my basement, and all the data just gets sent down to that hard drive. So I won't run out of space for a couple of years anyways. But it also allows me to save the original data before I start processing. It's something Brad was talking about, and Jim, you don't want to, be doing all of your analysis and calculations on your raw data and then have something go wrong and you don't have it. So I actually save that. So anyways, this is how I go through the planning process. And now the scheduler has it. And now I just go to sleep. I hit go and I enable the scheduler. And now it's going to know at 6 a.m. it needs to open up. It's going to go take the pictures. It'll save them. And, whether it's for me or, some of my partners, they know where to go find the data, once it's been collected. So that's, the basis of, just going and, figuring out what you want to do, putting the, the collections into the system. And you can set this up for, any number of stars or, astro imaging. And when the system's not busy doing this, on a clear night, it'll go off and, it'll do astro imaging, it'll do other types of observing based upon what people have just requested the system to do. So I was going to stop here. And then the last thing, when I come back around again, I'll just talk about, the data actually collected on this star and how it's processed and where I'm at so far. So I know I kind of left you with a lot there, but are there any questions or anything, any information I can give you?
So Chuck, I just want to say, if Dennis Conti were on, several of you on this call know Dennis. He's a longtime HAL member, and he's arguably one of the founders, if not the founder, of the exoplanet amateur exploration, if you will. And he's got a worldwide network now, and to the point where JPL and NASA, they use his organization's data to verify their own data that comes from some of the space observatories.
Yep.
So, and this is all done using same techniques, the variable star organization, and Dennis has presented to us 2 or 3 times, and he's also an award winner now, an international award winner. So this is really, really cool, and it's just an entirely different part of astronomy. Just a whole nother area to get interested in. And like you said, the tools are there. It's just a matter of making the time and trying not to overwhelm yourself on day one. But it's really very cool what you're doing there, Chuck.
Yeah, thanks.
Yeah.
And it doesn't take an exquisite setup either. People are doing this, just with smaller telescopes, setting them up for the evening. I just did this because, one, it was a fun project in and of itself just to plan and execute the building of an observatory. That was something in and of itself for me. Just being an engineer, I enjoyed that aspect of it. But knowing that, for me, that because I still am in the midst of my work career, having the time to do this, because I absolutely would not have time to do the things I'm doing if I didn't have a setup that was ready to go, just by opening up a roof.
Right. Yeah, that's
Yeah.
a benefit. that
It'll
many
be
of us don't
interesting
enjoy.
to hear your results. If they differ from the earlier study.
And I do have an O minus C diagram, which is observed minus calculated, coming up in the next section. And this one in particular, it has been changing. And I will share that.
So the session is continuing to record. I got a message that we've exceeded our limit as far as storage for Zoom on the cloud for the subscription that I have. But I deleted all the old sessions out, so I think it bought us more recording time. With that said, Jim, let's go back to you and get everything running.
Yeah, I think so.
Okay.
Okay, so while you were away, I went back and I set the alignment points so that I could at least talk about them if it froze up again. And basically what that's about is every one of these squares that you see on top of my image has a red dot in it, and that dot and the square around it is an alignment point, and each one of those areas is handled as a separate piece of the image when it actually goes into stacking. And I like to have about 30 to 50, and I've got actually 39, and that's controlled by the size of the alignment point. You can select numbers, but at this image scale, I had to up that to up the size to 264 to keep it down to something reasonable like 3940 alignment points. And then I just clicked on place AP grid, and all those squares showed. And after that, I clicked on this and I'm ready to stack. So I'm going to do that, and I'll talk a little bit more. And while it's stacking, it's just basically going through this list, doing all these things. The alignment is just basically making sure that a set of pixels that has a single feature, say this bright crater right here, they're all lined up on top of each other in the stack of 300 frames that's going to be pulled out of the 3,000 to be stacked. Let me talk about the sharpen just a little bit. I did an experiment with that. And I basically set the frame percentage, actually I set the number of frames to stack to 1, 30, and 300. And my theory was that if I just stacked 1, it was going to be my best frame and it would look pretty good. And if I stacked 30 frames, it would be maybe down here and that would look pretty good. And if I stacked 300 frames, I might be down in here. And I expected that to look worse. So I was just trying to say, what's the value of stacking 300 frames? Am I really making my data worse? Well, that turned out just the way I thought it would be. The 1 frame looked the best. It looked a little soft, but it looked the best. The 30 frames looked a little better, or a little worse. The 300 frames looked even worse. When I went to the set of frames for it that came out as a result of clicking on sharpen, the 1 frame by itself looked horrible. The 30 frames looked better, and the 300 frames knocked my socks off. Really, really sharp. So that kind of surprised me. So, and that's what I do. I select the best 10% and sharpen them, and then that's what I go with. Let's see. How do I have to stop share to go to another screen? So that's the end of the stack. That's all done.
We should just see whatever you see on your screen, we should be able to see,
Okay.
as long as you're in the
Let's see.
same window.
He's got it set to application.
Okay.
You're running on application?
All right. So I'm going to just stop share and go
Yeah, okay.
get another screen here real
Thanks,
quick.
Brian.
Let's see. So that's my my stacked image coming right out of Auto Stacker.
Yeah.
From that that run that you just saw would have produced the same thing. I've got this open in GIMP. Brad or Gene mentioned it earlier. You can see that I have some stacking artifacts here. I did have some drift. First thing we're going to do is crop that out. You saw Brad do some levels and curves adjustments. I'm going to do that, and I'll call it a night for this image. Here's my cropping tool. I'm just going to drag across the entire image and let go. I need to bring this over a little bit. And stacking artifacts show up around the edges. That's probably a pretty wide margin, but you don't have to go that wide. But basically, I've got good clean data on the inside, and then hit return, and there's my cropped image. So to do the in GIMP, which I only used just the other day to learn how to do this because I wanted to do everything in free software. Go to colors, curves, and I get basically a you see the curves? Yeah. You see my curves graph?
Yes.
Okay. This is a combination of levels and curves. And just to explain what you're seeing here, across the bottom of the graph, over to the left would be a pixel value of 0 or completely dark. Brad's 19 would be, maybe somewhere in here. And a value of 255 would be a completely white pixel. On the x-axis, for each intensity as you go, each intensity as you go across here tells you how many pixels. And over here, you can kind of see, almost hiding in the left edge, there's a lot of black pixels that represents this area of the image up here. And then all the rest of it that's very uncontrasty, that's all the rest of my data for this image. It's just right down there. So I'm going to do 2 things. This is like a levels adjustment. I'm going to drag the black point over, just similar to Brad dragging getting to the 19. Only my data is a lot farther from the edge than his was. And I'm going to grab the white point up here. I'm going to bring that over a little bit as well. Then I want to do one more thing. Brad did an S curve adjustment. That's your contrast adjustment. S for contrast. So just having fun there. So basically I'm going to bring the brights up a little bit. I'm going to bring the darks down a little bit. And I exaggerate that a little bit because I want, and by the way, Chuck is doing science. This is art. This is my interpretation of this image, and I want to highlight the brightness of the rays. And I do that with by bringing the points in as much as I did, and then the contrast adjustment. And I click OK, and that's my image.
So Jim, could you save that setting so you could recall that setting and run it over another image? So all those adjustments you just made, say, you know, you save it, name it, and then you could call it up again and just run it. So you do that in Registax.
Yeah, I don't know GIMP that well. I would imagine you can do that in PixInsight.
So let me tell everybody again, tell you, Jim, why I asked is the picture you see behind me, that is 9 sections all spliced together. And what I did is I got the best doing those curves and everything that you were just doing. I spent a lot of time doing it, and to get the one that looked just perfectly. And then when I stitched everything together, I ran that algorithm over the entire thing, and it balanced the shading and the contrast and everything across the entire moon. Otherwise, it's near impossible to do it if you want to stitch together multiple images. And, you know, because, you know, like down at the southern part of the sun, when you get the sun reflecting off of that big spray down there, it's really, really bright. And it could, you know, you get crazy kind of different colors or different brightnesses. So by saving it, you can pull it all up.
Yeah, it looks like you can.
Yeah, it looks like you can, but you have presets, which means you must be able to save it somewhere.
But again, I have not used that in GIMP. The 3 things that you just saw me do, that's really all I've ever done in GIMP. So that's all I can talk to. So with that, the next thing I want to do is I'll stop the share again and go grab something else. If I can find it. There it is. Do you see my
Yep.
photo of the moon? Okay, so this was just a random frame pulled out of the 3000. And next, this is stacked but not sharpened. That's sharpened. And that's my final result. And so there's the random frame and the final result.
Very cool.
Yeah. Any questions?
Jim, when I was playing with some moon images, and I found that I was doing, you know, the post processing in Photoshop, of course. I ran Topaz denoiser on it, and it really sharpened things up like to a significant degree. I was really surprised by how much it did. Have you ever heard of that or tried using that before? They have a free demo.
I do sharpening and noise reduction on planetary images as separate operations, because it seems like my sharpening creates noise. I don't think I'm seeing noise in this so much, so I just sharpen.
Yeah, it's weird the way that program works. Like it seems like it works best as like the last thing that you do. Like you apply all your sharpening and noise reduction and anything that you do, and then you just run that and just see what it does. Like it's pretty crazy because it's like AI controlled. So like it's kind of cheating because it's doing, it may be adding things that aren't really there. You know what I mean? But it looks nice, you know?
Right. Well, again, Chuck's doing science and I'm doing art. So I would like to add, you look at the limb of the moon here. Gene talked about the the diamond ring effect, and you see, the peaks and valleys there, and that's, the sun's almost more perfectly round than the moon is, and that's what you get those beads coming through in places like that.
Yeah,
Another bright
beige
crater
beads.
down here. I should have pointed out that I was watching some of these brightest spots, and like right there is completely saturated. If I'd have pushed more of this would have turned completely white, but I can see some less than completely white in there. So I was kind of just eyeballing that, looking. I was accepting some saturation, but not too much. But it was just a judgmental call on my part as to how much I wanted to accept. See more mountains up in here. All right, any other questions?
Thanks, Jim.
All right.
All right, so Brad, you still have something more? Or were you complete?
Well, I mean, I can always talk if you would like. Me
Well,
to.
we could ask,
I
let's see if
stuff
you
I
got
can-
any, or Chuck, you got something else to show, right?
Yeah, I've got the completion, the result.
Okay, go ahead.
Okay.
Thanks.
All right. Let me share again. Okay. And just FYI, here's the current sky situation here. So things are looking up for tonight. The latest dark sky, it's starting to clear. So I guess when we're done here, I'm gonna try to plan something for later this evening, because 2-3 o'clock in the morning, it's supposed to be pretty clear. Okay, so let me go back to here. All right, so I mentioned this TY UMA that I had been collecting on. So this was just one particular night in March that I collected an eclipse. I was trying to get a primary eclipse. I kind of knew about what time from that VSX software that I showed you earlier that gives you ephemeris and predicted midpoint times. So I did the planning, I set things up, I ran the plan, and I got 187 images over that time period. And so this is one of the images. This is a raw image, bin 2x2. The crosshairs, that is the star system that was actually imaged. This is actually image number 24 of the sequence. This is in Maxim, by the way. So I do use Maxim, to manipulate images, to do my my calibrations, which is what I was going to show next, which is applying the biases, darks, and flats. And so this is now what the calibrated image looks like compared to what you saw here. You can see a bit of a halo here, but now all of that has been removed. And so this is a now calibrated image. So I had 187 calibrated images. The next step was to upload them. Now, one of the things that I've been talking to Maxim about, because they do have a photometry module within Maxim. But remember when I showed you, let's see, where was it? I guess it was back on here. When I showed you this particular star chart, which is the stars, this is the target, and then these other stars in the frame are the comp stars. You can do the work in Maxim, but it has you manually enter all of this information for all of the comp stars and your target. Whereas if you use AAVSO's site, you upload all these images. It takes, 187 images, probably would take about 45 minutes for them to all load on the site. It's really easy. You just click and drag your images into a box. It loads them. And again, 3.2 megabytes each. So have a good connection and they'll be there within about 45 minutes. The other thing you have to do is have a sequence and defining the sequence for what you want analyzed on your on your frame. So defining where's the target. So in this case, here's the target. These were automatically put in here because, again, the people at AAVSO are really diligent, really supportive of amateurs, and they build these comp star charts for us. The tool automatically loads them. And then the next thing I do is I just run what's called a time series. I select all the images, I tell it to use that sequence, and it then does the analysis on every single image, does that differential photometry that I mentioned, which is we know what each one of these are to a great accuracy. We're just trying to understand what is this star on each image. And this is the result. So it ran the photometry, and lo and behold, on this night, there was a very nice eclipse. You can see this minimum time. Now, the question is, when did this minimum time happen? And was it per the prediction? So that's what I'm trying to do here, is not just, see whether or not there was eclipse, but to do some analysis. So one of the things that we do as amateurs, and in being helpful to other amateurs and to the professional community, and this is automatically generated just by hitting a button from this image, is to create this report, which gives the name of the star, the time in Julian date, and all the information about, which filter did you use, which, comparisons. And you upload this because now you make your data available to everyone and anybody that goes to this database. So I really wanted to plug that, because to me, this is the most rewarding part of all this, this is what gets left behind. And I'm looking at data that people started putting in back in 1967. So, I look at it as I'm contributing for, maybe there's going to be a supernova someday, or a nova associated with this star, and people are going to go back and want to look at data. Who knows? But I look at it as that, that's the contribution that I'm making. Now, I run another program called Peranso, which then takes this report and you get a light curve from it. And then I actually modeled the light curve with a polynomial. That's what the blue is, to fit a polynomial, because what I'm trying to do is understand where was the minimum point. What is the center of that minimum? And in this case, it actually gives me that time with an accuracy. And it was a brightness of 12.05, which is right in that range, that I expected, and a time that I somewhat expected. So this is the result, that I got just from that one night of observing. So it seems like a lot of work, to have done the planning, to do the, the execution, and then, the data reduction. But ultimately, what you're trying to do is to understand, hey, what does the whole curve look like? In this case, these are all the days I collected. If you can see the workflow here, this is TY-UMA and all those days that I collected in order to understand, where the points were. But ultimately, what I was trying to do is, can I model this system in another software called Binary Maker and understand what does the system really look like? What are the traits of the system? How big are the stars? Because again, I was trying to just perfect my own technique, or at least ensure that my technique is good enough to actually share with the scientific community, so I have some confidence in providing good data. So one of the things I looked at, remember before I talked about looking at different filters and what that does for you. So here's a light curve for this particular star. This is just from one night, where I actually caught, in about a 10-hour period, this was before daylight savings time, I got 3 eclipses, a primary eclipse and 2 secondary eclipses, but I did it in 2 different filters. So I just alternated between a B filter and a V filter. And as I mentioned to you earlier, when we looked at the Sun and Vega, this actually tells you something about the system. Because when you look at the difference in the magnitude of this star and you can compare a V observation at 12.06 and you can compare a B, which means it's much brighter, because we know that the magnitude system is inverted here. The smaller the number, the brighter it is. It's brighter in V than it is in B. And so this differential, there's actually tables that people have done and calibrated that Hertzsprung-Russell diagram. And based upon that differential, you can figure out what the temperature is for that system. And in fact, based upon what I came up with, it's about 5,500 Kelvin. And when I go back and I look in my book, hey, 5,500 Kelvin is what the primary star is in this system. So again, that's just something that I was able to do to kind of validate myself.
Chuck,
Yeah,
when you said primary and secondary eclipses,
yeah.
is that really what you meant to say, or is it really, just it was 3 eclipses?
No, there was yeah. So you have the system here where the first one in this case was a secondary eclipse, meaning that the bigger star was in front and the smaller star went behind the bigger one.
Okay.
And then I got the primary eclipse where the smaller star was actually passing in front of the bigger one. That's the one here in the middle.
Yeah.
And then it went around again. So because I had 10 hours of darkness and it was just a perfect night, that 8.5 hour, period here, I was able to get 3 eclipses in one night on this particular one. Okay.
Yeah, very cool.
Now, again, with that other software, so these are all of the nights that I collected. I could do some analysis to determine what is the period, what is the time from going from here to here. This is one revolution from this starting point back again to that starting point here. And so this software came up with a period of 0.3546. So, I mean, that might be a little hard to see for you, but that's what it says. And when I was telling you before about the planning data, and I was looking in VSX, well, here it gives the period that what was determined back in 1967, and it was 3545. So my period is pretty darn close to what the VSX said. So I'm thinking period looks good. The magnitudes are looking pretty good. But the interesting thing was when I started looking at comparing my eclipses, and this is the punchline here of doing something called observed minus calculated. The calculated is based upon an epoch that you use as a standard. And then you take your observations and you compare it against it, and you see how it varies over time. Well, I compared in the blue just against my own observations over a period of time. And it was pretty steady state over this, 20 some odd days, 20 some odd cycles that I did this. It was actually about 22 cycles. But when I compared it to the original in VSX, it was off by 0.1 Julian days. And when you do the math, that's 2.4 hours. So this thing has changed by 2.4 hours over the epoch that was calculated way back in 1967. So something has changed. The accuracy might have been bad, or the system has changed. So I didn't really know. So I went and I found a paper that was written back in 2013. And these people, it was somebody in Arizona, but then it was primarily a Chinese team that looked at this star. And they came up with an epoch. And when I compared my data to theirs, it was pretty steady state, but it was off by about over 0.04 Julian days, which is about an hour. So this system seems to be evolving. So that was the interesting thing for me. I mean, again, the reason I picked it was just to look at my technique, but then there were some results that seemed somewhat surprising to me. Now, the last thing I'll share here, I need to change what I'm sharing, I guess. I'll just go to my whole screen here. It'll be easier. Is this thing called Binary Maker. So this is the software that lets you model the system. In this case, what you see is there's a number of things you can input about the parameters of the particular star systems. You can put in the temperatures of the stars. You can put in other things about, like, what inclination, what is your point of view from the Earth looking at the system, because that changes how the eclipse look, from the Earth. If you're looking at, completely edge on, that would be 90 degrees. But if you're at a little bit of a tilt, it's going to change that geometry. The other thing that this program lets you do is it will allow you to take your particular light curve and do a comparison based upon, what you've collected and what's known about this system. And then you can do a rendering. And what this does is it basically runs you through the light curve, and you can see in the upper right, it actually shows, how the system, is revolving around itself, where the center of mass is. You can see the center of mass that it's revolving around is right here, because you have a bigger star, an F7 star plus an F0 star. So, you can see those geometries, and you can, again, it's just a matter of validating what you've collected against what is known about this one in particular, and allows you to, to figure out all those parameters. So, it's just kind of a fun thing for me to play with this and play with these different softwares. And again, it's just something, I'm very happy to share with people. I don't want anyone to feel overwhelmed. I only got started doing this, about a year and a half, 2 years ago. And it was because there were other people that were willing to say, I'd like to help you, if you've got an interest. So again, Jim, had some foresight, a couple of years ago, saying maybe we ought to, have some kind of a photometry section. And, again, I will offer, I'm more than happy to, to engage with any people that would be interested in sharing photometry.
All right, I want to show you guys something related kind of to this. Let me turn
You
off
want me
my
to stop sharing?
Let me turn off my background. Yeah, I'm going to hold something up to the camera. Let me turn off my background for a second. You guys can see all the stuff behind me. There we go. So this book, there's tons of good books out there.
Mm-hmm.
This book is called Searching for the Oldest Stars.
Yep.
By Anna Freebell. And it's just an awesome book. It could get a little bit heavy in points in some of the math and some of the diagrams, but what Chuck is talking about there's a lot of explanation in all of this stuff. I wrote Anna Freebell an email. I found her email address. I sent her an email because I had a question about something in the book. She responded to me like within an hour. She's a German astronomer, and she's currently teaching at MIT. And I'm going to try and reach out to her and see if we'll get her to talk to HAL. I'm having pretty good luck with some of these famous people lately. So her accent's pretty thick. Her German accent's pretty thick. But I watched part of one of her YouTubes, and it should be fine.
It is amazing, that these people who are doing some heavy duty science, they are more than willing to talk to you. I mean, I just email people out of the blue and ask them questions, and they are very happy to share their passion and what they're doing. And look, Matt, there's a guy named Matt Nolte or Nati that is studying a specific effect that's going on with eclipsing binaries, where they are asymmetrical. Yep. And I just reached out to him after watching a webinar, and he's given me, hey, if you want to help, here's some stars. I could use some help if you want to collect images for me. So, it's just wonderful that these people are willing to, to want to, talk to us and include us.
Yeah. So, and Chuck, as you can see, you and I did not rehearse, but I do have my homemade radio telescope behind me there, but also my Hertzsprung Russell diagram on The floor behind me.
You know, it would be really neat to bring in some of the Green Bank, use their telescope, or even, some stuff that others in HAL do with radio astronomy, because taking radio velocity is another thing that people do with radio astronomy with eclipsing binary. So we could combine much of this too.
Sue Ann sent me the address for the site that you talked about and the code to get in there. So I'm going to just distribute out an email. I think I'm going to have Ken put it on the website. And so people could come, grab that information as they want, if they want to go in and do some citizen science with that stuff. And that'll have maybe some of the information you're looking at for. If not, I'll just contact Sue Ann and we'll find out if we, where we can get at that variable star data. So
can we get Sue Ann's presentation? She showed us a lot of super nice, super impressive radio the telescope image. I just hope I can show my kids or families those pictures.
Yeah, so if you go to the that session wasn't recorded, but if you go to the Green Bank Observatory website, you could find your way through that website into a lot of those images and a lot of that science, and also through the National Science Foundation and National Radio Astronomer Associate Organization, NRAO. So they're all there.
Okay, yeah, thank you.
Yep. So
and I hope we, Thursday we also talk about the radio telescope, and a member show us his homemade system. I just hope we can go over how he built it, and probably like I am interested. I probably I want to start such a project. If somebody can show us, that'll be great.
Well, I've been taking some notes as the team here has been presenting and you've been asking questions. So I'm adding that one to the list. One of the things that Brad and I were talking about that came out of an earlier meeting before everybody joined in is what I'm going to get. I'm going to run a special meeting for our May monthly meeting where it'll be an open forum and we won't have an outside speaker. We have so much expertise and so many people with so many questions right here in our own club. Going to take advantage of it. Some structure. But one of the things I'm going to do is I'm going to get a good set of data from somebody in the group that's got a lot of high quality data, and have that placed in our website for everybody to work with the same data, to come out with to be able to do their imaging from the same data. Like Jim was joking around and others. When is an image finished, right? When you finally give up on it. And that is a contest, but it could be used for a couple of different things. I don't have any desire to do any internal contests, but to have people process the data in their own ways, see how they turns out compared to others, and how many times do we look at the same image month after month after month, or I should say the same object, and it looks different because of the way it was processed or the amount of data that was included. So the other thing we could use that common set of data for is for an instructional session where everybody's got that same data, and we could do astro school. Jim did his astro school on the celestial sphere over 3 sessions. We could do the same thing with, a group of people who want to work with that same data and go into, different sessions on how to process different parts of that same data. And everybody will have, their own homework if they want. And it'll be really cool. It'll be fun. And I'm looking forward to launching that program in May. So, Mangan, I got it. I hope I pronounced your name correctly.
Yeah, you did. Mengnan. Yeah, thank you.
Yep. So, yeah, this is great. Hey, one thing that I don't know how many of you joined our polar alignment session we had a couple weeks ago. It got much more in depth, and I'm saying that as a pleasant surprise than I was expecting. And Gene's got something that he's ready to share, and to add some little additional information onto that. So Gene, you want to pop in with that?
Yep, sure.
Okay.
Yeah, I'll just do this real quick. I'm not going to go into
Okay. Yeah.
a whole bunch of, all right. Oh, yeah, so, right, now I can't remember who did it. Oh, John, was that his name? John gave a talk about polar alignment, and he mentioned some of the other ways. But here's a different way of doing polar alignment, which actually, I mean, this is actually the way I do it, but it takes a little longer than the other ways. So I don't know how, if other people would ever wanted to use this, but anyhow, it's, it uses, well, the SkyX is software that Chuck mentioned, and it's made for the Santa Barbara, no, wrong system. Whatever, the Paramount mounts, but it works with, yeah, software BISC. Yeah, they're both SB. It throws me off. Anyhow, works with the Paramount mounts, but it also works with other mounts. But the idea is, well, I guess the one advantage it has is you don't need to be able to see Polaris, although you do have to start with your mount pretty close to Polaris. But you can do that like with a compass and getting the elevation right. But what you do is it will do a automated calibration run. So basically all you really have to do is you tell it, where does it start? Wrong one. No, I don't remember. Oh, setup. Yeah. Oh, well. Anyhow, you tell it how many stars you want it to use, and then you just let it run, and it moves your mount and points it in different places in the sky and takes pictures. And then it figures out from the stars that it sees where it's aimed. And when it's all done, it prints out, like Chuck was saying, it prints out this report that shows you how far off your mount is from being correctly aligned. And then you can run this accurate polar alignment thing, which I won't go through because I'm not hooked up to a mount. But basically the end result is you aim it at a star, and you say, okay, I'm aimed at a star, you hit a button, and it offsets that star by how much you need to correct the aiming of your mount by. And so by not using your RA and DEC, but just by using the azimuth and elevation, you turn the mount so that the star is back in the middle. And now you're polar aligned, more or less. Well, hopefully, it depends on how many stars you use. The more stars you use, the better it does. So you have to sit there and wait for it to go through all these stars. Like this is one where it used 28 stars, and it just goes through here and, takes like 15, 20, half a minute per star. And when it's done, so you're not doing anything, you're just sitting there watching it. And when it's done, you go through this polar alignment thing. And so it's, it's kind of useful. The other thing that this does, and I think the SkyX only uses mount modeling for Paramount mounts, but there is other software that will use mount modeling for other mounts. And what mount modeling does is, well, the reason you want to use it is because it figures out where your mount is really aimed and makes corrections for things like, like everything bends. Your mount weighs 100 pounds and it's made out of steel and all this kind of stuff. It still ever so slightly bends, and things like, and the telescope itself also bends. And probably the worst part is that, well, if you have a reflector, at least a Newtonian reflector, well, even maybe an SCT, the thing that holds a secondary mirror, it can only be so stiff. And so that the secondary is ever so slightly moving around, it's sagging and all, depending on which way the telescope is aimed in the sky. And to do that, you would use more stars. But what it does is it points somewhere in the sky, and it takes a picture, and it knows where it thinks it's pointed. It takes a picture, and by doing a plate solve, it figures out where it really is pointed. And then it knows, and it does it for the whole sky, and it can build up a model of where your mount thinks it's pointed versus where it really is pointed. And then as you're taking deep sky pictures, you're taking long exposure pictures, it can, at least with a paramount, it can actually ever so slightly change the RA and dec rates to make up for the fact that your mount is not really pointed exactly where you think it is. And because of, all these factors that it figures out, it corrects for all that stuff. And so supposedly, I never do it, but like Chuck was talking about, supposedly you can get pretty long exposure pictures without guiding, because it's taken into account a lot of the problems that cause your telescope not to guide correctly.
So Gene, because I have a permanent pier, I ran a 330 point mount model, and it took about 5.5 hours. It pained me just because I wanted to do it on clear night, and I hated to use up that much clear night time just to do a mount model.
Yeah.
But it was worth it in the end.
Right.
Hey, Gene, can you hear me?
Yeah.
Hi. I'm curious about the next to last column, scope deck. Those numbers look really funky to me. This deck goes from -90 to +90, and I'm seeing 123, 145.
Right. So I'd have to look up what it means. I don't know.
Okay, just curious.
Yeah. I never noticed that, but yeah, they don't match up with the star deck, at all. Like this is 62 versus 115. So these must be different using.
That's obviously different coordinate systems, but it just seems like an odd number to be labeled as declination.
Right. And some of them are negative. So I don't know, it's like I could see if it was going from 0 to 360 or something, but there's negatives in there too.
It probably goes up to 180 max, that whatever this is. It probably goes from -180 to +180 from what I'm looking at.
Yeah, Gene, I can tell you mine's doing that too. I'm looking at my existing mount model here, my calibration points, and I have the same thing.
Yeah, so I have no idea.
Okay, just curious.
Okay.
Well, it'd really be a problem if the star deck was doing that.
I agree, yes.
Yeah, so one of the problems with this is if you move your mount around, this is perfect for if you have a fixed mount. But I think I'm assuming that as long as I don't change anything, I have the same camera, everything's balanced the same, that even though I do it one time and then take the telescope in and bring it back out again, so long as everything's pretty much the same, it's probably, not going to come up with too much different answers. And you can run, like I guess mine go faster than yours do, because I can go through one iteration in like 30 seconds. And one night I did 600 and it only took like 3 or 4 hours. But so you actually can do, like if you're going to go to a star party where you camp out, you can spend, like the first 3 hours of the first night getting a good star model built up. And then for the rest of the time, you're good. Anyhow, so
Cool.
I will stop sharing.
Very cool. All right, everybody, it's 10:30. Jim, did you have a couple more pictures you'd like to show that are already done? You got to unmute.
Yeah, if you want to keep going, I got stuff I can show.
So hang on for a while longer.
Oh, we still got people on, so let's
Yeah.
keep going.
Yeah. We're scheduled till 11, so.
Okay. Let me try and get something up here. It's hard for me to see what's in these.
Hey, Marty, I saw you might want to add something, so jump right in when you can.
It's all right. It's
Go ahead,
fine.
Marty. I need a minute.
It's all right.
So I've been asking Marty, for everybody so I know, to plan a session for us, maybe in Astro School, even on eyepieces. And for the observer. You remember, there still are eyepieces that are out there, and still people put their face up against their telescopes.
Wait,
And
you mean you can look through these things?
yeah, it'll be a special session for how to actually look through a telescope with your eyes. And when you really get sophisticated, we could talk about bino viewers when you can use both eyes at the same time. Choosing the right eyepiece for the right telescope. There's like everything else we talk about it, to do it right, there's things you should know, right, Marty? So
Absolutely.
Okay, just to talk about what Gene and Chuck were talking about. Talking about very precise methods of polar alignment and knowing where your scope is aligned and stuff like that. Myself, I think Victor Sanchez, we use a slightly more shoot from the hip approach. We will get the best alignment that we can. And instead of doing a star alignment, we'll slew to the target, have it plate solve, see what the error is, and then it will close that gap. It might take 2 or 3 images until we're on the target, and then we're ready to start imaging. So we just kind of simplify it, and it's not nearly as precise. Definitely, if you have a fixed fixed location like Chuck does, you don't have to take it down. That's the way to go.
Hey, Jim, let me interrupt for a second. So Chuck is dropping off. I don't know if he's already jumped up. No, he's still there. So Chuck, I want to thank you tonight for everything that you presented. It was awesome.
Absolutely. Thanks for inviting me again. And, like I said in my message, and sorry to interrupt you, Jim.
Sorry.
I have an observatory, and, it's, I wanted it so I could share it. So, I mean, we've got a club here, we've got people who have interests, whether it's, astro imaging or, science. I'd be more than happy to, to work with people, schedule things, images, or just doing some projects together. So, please just let me know.
Thank you very much. All right,
Okay.
have a good night.
Thanks.
Have fun at the races tomorrow.
All right, thanks. Bye-bye.
Back to you, Jim.
Yeah, as Chuck mentioned, he characterized himself as somewhere between advanced beginner or beginning intermediate or something like that. And I feel like I'm kind of in the same boat as far as astrophotography. This doesn't happen all at once. I actually started playing with this stuff like 12 years ago, and still working, heavily involved in HAL and getting the observatory up and on the board for a while. And I didn't do very much of my own astronomy, but in the last year, you asked me what did I do during my my COVID break? Well, I really buckled down and started working on some stuff and made a lot of progress. So it just takes getting out there and doing it. And I like to say you got to learn new things quicker than you forget old ones to make progress in this. So there's not, as you saw with the processing I did, there's absolutely nothing hard about this. So this image is the one that you saw, well, you see behind me now is I attempted to capture the full disk of the moon the way Phil did with the one behind him. And I had some issues in it. You can see some white at the lower edge down there. Had some issues and my data stopped flowing to the hard drive for some reason, and I gave it up. I abandoned it after 15 minutes. That's probably about 8 frames with the same camera. The picture that you see that I'm sharing, similar approach. It's about 5 camera frames, I think, maybe 6, probably 6. And I combined them in Photoshop. It was very seamless. The scale's about 0.24 arc seconds per pixel, or 4 arc seconds within a a pixel. That's probably a better way of saying it. So it's a very large, very fine amount of detail here. So you can start to zoom in on this and really start to see some detail there. Like
That's a great
there's,
picture.
you see a reel running through the valley there. Um, um, there's another reel coming down through there. See plateau and slumping along the edges. This is Mare Imbrium and the mountains out there in the middle of the Mare. The wrinkle ridges in there. Just all kinds of detail that you can see in these images. I used to know what that crater was, but I forget. Come back up this way and there's the mountains on the edge again. So back over where to? Back over here. That's the crater I had before. I just, the light was different. I just didn't emphasize it as much. But so the same technique, I just didn't do as much contrast. So that's what you can do with lots of images put together. I hope to one day do one of the full disk of the moon at that scale and have it printed. That's all I have on that one. Any questions?
That's just very great.
Mare Frijoris across the top of the screen. That's what I titled that one.
Got such a 3D pop. It almost seems better in the photograph than it looks on telescopes.
Yeah,
Yeah,
that's a great view.
thanks.
Did you say that was just 8 images that you took?
I think 6.
6.
Yeah. This gray spot down in the bottom left, I think that's where I had a gap for some reason. I used that to put my description in
And
there.
you know, Jim, when you're at high power on the moon and you're getting a lot of images and trying to put them together. Now, if you're doing it with the AVI, you know, when I do it with TIFF files or FITS files and stuff, they're very large single frames. But, you know, with the atmospheric movement and stuff, you get a lot of variables in those images. And that's where those stacking packages make a difference because they'll throw out those bad frames.
Yeah.
And so sometimes, you know, with a really steady night, you could do tremendous things. On a wobbly night, you know, it's the same problem I have with the sun. You know, if you get the sun, if you've got a good horizon, you could do it relatively early in the morning before everything starts boiling. Or if you're over at Company 7 with Marty in the parking lot and the sun's over the roof, you get all the, you can see all the heat bubbling off the roof. And it affects your images too if you're trying to stack them. But this is really, really good, sharp detail.
I would add there that each one of those 5 or 6 camera frames that were blended together, each one of those was a run of 3,000 frames that I stacked the best 300.
Yeah. Yeah, I'm going to start doing that. I haven't done that, running AVI files like that. And some of the planetary stuff in the moon.
Really makes me want to get a longer focal length scope for doing that kind of thing. That's really awesome.
All right,
Well, Marty can help you out.
Yeah, this is at prime focus. There's when I have tried to put a 2x power mate in there, basically the craters stop looking like divots and start looking like bumps, like the top of a McDonald's soft drink lid. And then I get compulsive, obsessive, and I start trying to pop them back in. I spend all night doing that. So haven't had very much luck with the going in with a power mate.
You know, when we were talking about all the polar alignment that we've been talking about over the last month and in our sessions, and that tight of polar alignment is, the better it is. I mean, it's obviously good for everything, but it's necessary for, you know, long exposure, deep sky, you know, all that kind of stuff to be, you know, at that level of preciseness. But when you're doing the moon and the planets and stuff like that, you don't need to be that tight all the time, because one is you're shooting with bright objects, you're shooting very fast. And and especially with the sun, you're shooting super fast.
Yeah, the process is very forgiving.
Yeah.
Even though I have drift, the alignment, or the registration, whatever you call it, this line figures
Yeah.
everything out and lines it back up perfectly, even though you have some drift over the course of a video run.
Now, one thing that I did that was really cool. Let's see if I can turn this camera on without making real noise. Picture up here. What I did is I turned off the tracker on the telescope altogether, and I just let the moon run through the, just let it run through the, just naturally drift across. And as it did, I just clicked lots of images all the way through. And then I stitched them all together in Photoshop and got that very high resolution southern hemisphere of the moon there. And it worked out awesome. And there was obviously no trade, it was just the natural motion of the moon relative to the Earth. So all kinds of cool things you could do with the camera.
One of the things that not a lot of people mention about shooting the moon is you can use nature to have a dramatic impact in the end result. And very few people think about it, but the relative distance, the distances between Earth and the moon vary throughout the year. So what you want to do is you want to use this time to get good at shooting the moon in practice, culminating, I think this year, for example, I think it's around December 7th or 4th, it's the early December, we're going to have the closest approach to the moon. And it will have a noticeably bigger moon. It will be brighter as it gets closer to us. You'll be able to get faster shutter speeds, bigger images, still well within the reach of any of the scopes that we're all using. Most of us are using that can shoot half a degree depending on the sensor. So use the rest of the year to practice, but hope that the weather's clear and you can go for your money shot when we're really close. Years ago, I took a trip to Nova Scotia to see the tides. Some of the highest tides on Earth, almost 48 feet or so at Hantsport in the Minas Basin of Nova Scotia, north of Halifax. And I planned it based on the opposition that year. The closest approach was going to be, I think, in June. And so it turned out to be a good time of year to be there. Turned out good weather for astronomy, and the tides were even more dramatic. If somebody wanted to shoot the moon, it would have been a great time to do it then. I wrote an article, it's in Company 7's website in our library. I think it's Exploring Nova Scotia and Its Amazing Tides or something like that. And it talks a little bit about how different the distances can be between the Earth and the moon throughout the year and even over decades, and the impacts it can have on things like the tides, for example, and
Yeah.
the size of the moon from Earth.
Yeah, we can. So one of the things that Ben Schumacher, Professor Schumacher, talked about at our HAL meeting in March. You know exactly what Marty's talking about, and in a session on gravity, and a lot of the stuff that Chuck was talking about today was some of the things that they talk about a lot when you study quantum mechanics. There's a great shot. Wow, very nice, Jim. Where you been hiding these?
On my Flickr page.
Yeah, I'll have to go back through your Flickr site.
Yeah. There's Copernicus, just barely inside of the Terminator runs through here, so barely inside. Eratosthenes over here, and what I particularly like about this is the detail in the rampart, the ejecta field surrounding Copernicus, and you have the lines of craterlets. Love that. Down here in between, you have a ghost crater called Stadia. Because the sun angle is so low, it really stands out. I doubt that you can see this in the full moon. You see the debris field from Copernicus, wrinkle ridges. Yeah, I like this one a lot. Thanks.
Wow, that's a spectacular shot. Anybody else have anything else? Any questions you'd like to show, talk about? If not,
Oh,
so somebody say something?
I was just saying thank you. This has been really great.
You're welcome, Chris. You and Jared for joining and everybody else. This has been great. You know, and I almost want to say, I'm sorry that the skies weren't clear and we couldn't do any real observing tonight, but we wouldn't have done this tonight if the skies were clear. And I think, you know, the fact that almost everybody stayed on till it was 10:30 at night was a testament to how interested everybody was. So I want to thank Brad and Jim and Chuck and Gene. Am I missing anybody for showing everything? It was just great. So stay tuned. I'll put out a notice for what we'll do at the in the May HAL meeting. And this has been recorded, so I'm going to officially thank everybody right now, and I'm going to stop the recording. And so here goes, it is.